Rutherford's model could not explain a lot of features. Number one, stability of the atom, most important one. Stability of the atom could not be explained by Rutherford. Number two, at that time, hydrogen atom was shown to emit certain radiations when they were de-exciting. Excitation and de-excitation, at the time of excitation, de-excitation, certain wavelengths were emitted. This is known as hydrogen spectra, which again could not be explained by Rutherford. So, another scientist by the name Niels Bohr, he gave his model, which after his name only is called as Bohr model. In Niels Bohr's model, what happens, what he says, you see actually everything he keeps of Rutherford only, nothing new. He says that atom consists of most of the vacant part, same like Rutherford. Now, total mass and total positive charge is concentrated in a very small space called nucleus, and electrons revolve around this. Now, the thing is, only difference which he made in Rutherford's atomic model was that when electron is moving in its orbit, it does not evolve or emit or absorb energy. This is the only difference which he made. He said that electron cannot revolve around the nucleus anywhere or wherever it wants. It can revolve around the nucleus only in such certain spatial circular pathways, which he called as orbit. Now, this orbit, he said, will be only at specific locations around the nucleus and not everywhere or anywhere. He did some calculations and he gave that electron can revolve around the nucleus only in those pathways where its angular momentum, mvr, is equal to h upon 2 pi or its multiple integral n. Means value of n will be either equal to 1 or 2 or 3 up to infinite, actually less than infinite, but in multiple integrals of h upon 2 pi only. This is what Bohr said. Actually, Bohr could tell a lot of things, so Bohr was highly successful at that particular time because it could explain almost everything. It could tell the radius of the orbit, it could tell the velocity of the electron in that particular orbit, it could even tell the energy of electron in that particular orbit. How? We'll do some derivations now. Okay, we'll do some derivations now. And what happens? The two things we have to understand here. When electron is revolving around the nucleus, at that time two forces will work on the electron. One will be attractive force of the nucleus, which will pull it towards itself. Other one will be outward force, which will force the electron to go outside. It is simple like you tie a stone with a thread and you start rotating it. So, to hold the stone at the same point, you are pulling it towards yourself. You have to apply some force. If you cut the rope, it goes out. It goes away. Right. So, two forces working on the electron also. One is centripetal force, inward force due to attractive forces, which can be given by Coulomb's law. And Coulomb's law says that F force equal to K Q1 Q2 upon R square. Here, this distance will be r, this can be taken as q1 and this electron charge will be q2. Right up now. Now, this will be equal to k q1, this one here. Suppose we have got z protons here, so electronic charge is E, charge on electron and proton will be same. So, total charge on the nucleus becomes Ze into q2. This is electronic charge, which will be E upon r square. This is radius of the orbit in which electron is revolving. This will be equal to, this is centripetal force, and this must be equal to centrifugal force, which is given by the formula mv square by r. Right. Now, obviously, if electron is balanced and it is revolving in its orbit, that time centripetal force and centrifugal force must be equal to each other. The second condition which Bohr gave for the electron to move in its position was that mvr, means its angular momentum, must be equal to multiple integral of h upon 2 pi. Actually this n, this orbiter is nowadays also called a shell or shell number here. Now, we will do some derivations now. What we do from here, that from this second one and first one, from these two equations, we are going to derive two formula. One will be of radius, other one will be for velocity. From here, we get kz square upon r square. This becomes kz square upon r square. We get equal to mv square by r, right? And from here we get mvr equal to nh upon 2 pi. If we calculate v from here and substitute in this equation, and similarly we calculate r and substitute here, we get r equal to n square h square upon 4 pi square m z e square. This is the formula which we get for the radius of a particular orbital here. In this formula, if you see, n here is orbit number, h is Planck's constant, which is a constant. This is again a value, pi again a constant. This is mass of electron, which again will be constant, 9.1 into 10 to the power minus 31 kg. This is z, which is atomic number of that particular atom for whom we are calculating the radius. E here is again electronic charge. If we substitute the value of all these constants, we get r as equal to 0.529, 0.529 into n square upon, this comes here, z. And this value is in angstroms. Suppose we are given a question that calculate the radius of an electron present in third shell of Li2 plus ion. All these formula are valid only for single electronic species. All these formula are valid only for single electronic species, not for any other species. So what we are going to do here is, we are going to calculate for Li2 plus ion, lithium 2 plus ion. Third shell, what is the radius of the third orbit of lithium 2 plus ion? Simply we will use this formula, equal to 0.529, n is 3, so this becomes 3 square. Z for lithium, atomic number of lithium is again 3, so we put it 3. If we solve this, this gets cancelled here, and this will be the radius of orbit of the lithium ion in the third shell. If we go for velocity, v, we get v equal to 2 pi z e square upon nh. Now again see, this is the formula for velocity, and in this formula 2 is a number, pi again constant, z is atomic number, e again electronic charge which will be constant, n here is shell number or orbit number, h Planck's constant. Again if we substitute the values of all the constants, we get a value which is 2.18 into 10 to the power 6. This comes like this only, into z upon n here. Z here is atomic number, n here is shell number. Again if a question is asked that calculate the velocity of an electron present in third shell of Li2 plus ion, how it will be done? See, 2.18 into 10 to the power 6 into z, third shell, so lithium ion, so z will be 3, third shell, so n will be 3, gets cancelled, so we get 2.18 into 10 to the power 6, and the answer is in meter per second. Like this we can do it. Right, now see, once in IIT one question was asked that find how many revolutions will be done by an electron present in third shell of Li2 plus ion. How that can be solved? Easily it can be solved. See, number of revolutions done in 1 second in third shell of Li2 plus ion. What we can calculate here, what the speed of electron at which it is moving from here, right, from there. Now see, suppose one question comes that calculate number of revolutions done by an electron in third shell of He plus ion. In third shell of He plus ion, we have to find number of revolutions in 3 seconds. This is what we have to find. This becomes quite simple. How? We can find velocity by using Bohr's formula. We just studied that one. This is the distance which is traveled by the electron in 1 second, v, because in meter per second we are getting it. So electron travels v meter in 1 second, right? Now what happens that if it is given in 3 seconds, so in 3 seconds distance travel will be v into 3. This becomes total distance traveled. If electron travels 2 pi r distance, at that time it makes 1 revolution. This will be circumference of the orbit of the electron. This radius again we can find from Bohr's model, right? Just that formula also we studied. So radius we can calculate from there. If we multiply with 2 and pi, then it becomes circumference of the orbit of the particular orbit here. Now this is the distance traveled in 1 revolution. If both of these are divided, this is total distance traveled, this is distance traveled in 1 revolution, then this becomes number of revolutions traveled by the, done by the electron. This becomes number of revolutions done by the electron in third shell of He plus ion in 3 seconds, right? So this type of problems also can be solved easily. Now, actually Bohr was highly successful at that point of time, because it could tell almost everything about the electron. The most successful point of Bohr's model was it could explain the spectra of hydrogen excellently. What was found that when hydrogen gas, if we take it in a chamber, in a container, if we take, this is hydrogen gas, monoatomic gas, this is not H2, this is H. If we take hydrogen gas, and now this is irradiated with a lot of radiations or different wavelengths, electrons absorb them and get excited up to some level. When they de-excite, at that time certain radiations are emitted by them, and in spectra, if we take a spectra of them, we get lines in that spectra. These lines could be predicted by Bohr's model perfectly. Exact positions of Bohr's, those spectral lines could be predicted by Bohr. Bohr's model, we will go into detail now. What Bohr says that we have got nucleus which contains total charge as well as total positive charge of the atom, and electrons revolve around the nucleus in circular pathways in which they don't emit or absorb energy. As long as they are in same pathway, at that time they don't do anything, simply keep on revolving there. He further said that electron will revolve only in those orbits where its angular momentum is equal to nh upon 2 pi, that already we discussed. Now, he further says that actually this is multiple integral of h upon 2 pi, means we can have lot of values of n starting from 1 up to infinite minus 1. Means we can have some more orbits for an atom, for an electron like this. This will be first shell, second shell, third shell. If we call this one first shell, then this will be second shell, third shell, fourth shell, or orbit. Shell and orbit actually are same thing only here in this case. Now, Bohr says that it is not so that electron never emits or absorbs energy. They do, but when they are changing their orbitals, only at that time they emit or absorb energy. For example, if electron goes from first shell to second shell, the equivalent amount of energy or difference amount of energy will be absorbed by the electron. Similarly, if it goes from first shell to third shell, then again the difference amount of energy will be absorbed by the electron to go from there. Similarly, when the electron de-excites from some higher shell, at that time, suppose it comes from fourth shell to third shell, the difference amount of energy will be emitted by the electron, and this emission will be again done in form of photons, which already we discussed in Planck's concept. Now, this actually could be explained by again Niels Bohr, because he could give even the energy of the electron perfectly. Energy of electron according to Bohr is given as E equal to minus 13.6 into Z square by n square, and this energy value comes in electron volts per atom. The relation also I'll tell you in electron volt and joules. We have 1 eV means 1 electron volt equal to 1.6 into 10 to power minus 19 joules. So we want to convert this, the conversion factor here. In this manner, electron volt can be converted into joules. How electron volt comes, that also we'll discuss later on. This is the formula to calculate energy of electron in a particular orbit of a particular atom. For example, suppose it is asked that calculate energy of an electron in third shell of He plus ion. How it will be done? Very simple. This electron, we are going to calculate energy of electron in third shell of He plus ion. So energy will become equal to minus 13.6 into Z for helium will be 2. So this becomes 2 square upon n square. N, it is third shell, so we put 3 here. It becomes 3 square. And this will be energy of electron in electron volts per atom. This is for one atom per electron. Okay, now what happens here? Suppose electron transits from one particular shell to other particular shell. Achha, one more thing I'll tell you here. The meaning of negative sign here. We are putting negative sign here. This is highly important because as long as electrons remains in the atom, it must have a negative sign for the energy. This shows that electron is bonded to the atom. Once electron gets positive energy or zero energy, it is out of the atom. It is not in the not in the atom. Now, same way we calculate ionization energy also. For example, suppose we have to calculate ionization energy of hydrogen atom. For hydrogen atom in the first shell, the energy of electron will be minus 13.6. Same formula we are going to use. Z for hydrogen will be 1 square upon n for hydrogen. If it is in first shell, it will be 1 square. Electron volt per atom. Now, this comes out to be minus 13.6 eV per atom. This is energy of electron when electron is present in first cell of hydrogen atom. If we want the electron to get out of the atom, then its minimum energy should become 0. And to make it 0, how much energy should be provided? That should be obviously plus 13.6. If it is provided, then net energy of electron will become 0. Got it? That is how the ionization energy becomes of hydrogen atom as equal to 13.6 eV per atom. If this much energy is provided to the electron, it gains the energy, comes out of the atom with 0 kinetic energy. Any amount greater than 13.6, if you provide to the electron will gain that energy. Suppose you provide 20 eV energy to the electron, 20 eV energy if you provide to the electron, then out of this 13.6 eV, it will consume in coming out of the atom, and remaining energy will get converted into its kinetic energy. But as long as electron is present inside the atom, it absorbs or emits only certain values which correspond to difference of the two energy levels. Now, one example, if suppose electron comes from third shell to first shell in hydrogen atom, that time energy emitted by the electron